The generalized barocentric coordinates has big error to visualize the data. We propose 3 algorithms named distance space layout, iterative error reduction, and force-directed adjustment to reduce the layout error of variables to variables, data to variables, and data to data respectively. First, we use DGBC to reduce the variables to variables error. We can find the error reduces a lot, 49%. The DGBC can preserve accurate variables layout. Second, we consider the data to variables error. It is high, too. We apply the IGBC to reduce the data to variables error. It reduces 25%. Third, we want to reduce the data to data error. We propose the FGBC to reduce the data to data. The result shows it reduces 28%. Finally, we combine these 3 algorithms together and get the DIFGBC. The overall error reduces 44%. In order to see the details of the error of data and variables, we develop the errorviz panel. It applies the heat map to show the error. For example, we want to know the error in terms of the variable origin. We pick the second line of the errorviz panel. We find that the top points have lower error than the bottom ones. We can also find the first 4 variables have lower error than the last 3. Overall, the error in terms of this variable is a little higher than the other variables. Finally, we developed the GBC Error Explorer for case study to provide an interactive visual analytics interface by which users can explore different layout strategies to provide the desired insight. It combines parallel coordinate display, distance heat map, layout display, errorviz panel, and configuration control panel. The parallel coordinates display provides an overview of the dataset to help users understand the data values. The distance heat map visualizes the distance of data to data, data to variable, variable to data, and variable to variable. We believe that it helps users better understand the relation between data and variables. The layout displays the main display of our system. It shows the layout of the distance matrix. The errorviz panel visualizes the error of the layout. Finally, the configuration control panel allows users to manipulate the various parameters of our system. From this system, first, we can observe the data has 3 groups from distance heat map, but the GBC plot overlaps a lot. We also find the error is high. So we use our DIFGBC method to reduce the error and lay out the data and variable points again. We find the errors in terms of the data to data, data to variable, and variable to variable become much smaller. However, we find it is hard to tell the other displays of one specific cluster, so we filter one cluster to see its features in more details by use of other displays. From the information we get from the parallel coordinate display, distance heat map, layout display, errorviz panel, we can confirm the GBC plot keeps this cluster data distribution and features. We provide another complex example using bike data. First, we find the error is really high. We also use the DIFGBC plot to reduce the error. The new layout is more accurate and provides us more clear features. However, it is still hard to know more details this distribution. So we choose a specific variable and to show the data and variables. Distribution according to this variable. We can find the points near the variable have the high values, and those far away from variables have low values. Similar to this, we can plot the error distribution according to this variable. We can find the high error area as well as low error area. Second, since we find that it is hard to find the feature of each data cluster, and also we want to reduce the error again, we apply the local refinements. The data-centric refinement aims to pick the subset of the group and lay out again. Now we find it is much easier to see the cluster features. The variable-centric refinement is to choose one subspace and lay out the points based on this subspace. For example, we choose a subspace with the related variables, such as temperature, count, causal, etc. We find that these bikers form three different groups from the parallel coordinates, but the GBC maps them all in the center. We can confirm these groups are well distributed from the distance heat map and the GBC plot. The variables also form three groups representing the temperature, the number of bike and casual factors respectively. In addition, we also find the layout error becomes smaller.